Commonwealth Edison of Chicago has spoken at each Recloser workshop since our first workshop back in 2016. Today's presentation will be co-presented by Marina Mondello and Ammar Mirza. Marina Mondello is the Senior Manager of Distribution Capacity Planning and has been with ComEd for 19 years. She was previously in the Reliabilities Program Department in the Distribution Automation Group, which monitors and troubleshoots the distribution automation system at ComEd, along with developing settings for DA equipment. Prior to the DA group, she was in the distribution testing and new business departments. Marina received her Bachelor of Science Electrical Engineering from Rose-Hulman Institute of Technology in 2000. She was also awarded the prestigious 2018 IEEE Power and Energy Society's Pioneer in Power Award for her work mentoring young women in the power industry. Ammar Mirza joined the Distribution Automation Group in 2019 as a program manager and has been with ComEd for 13 years. In his current role, Ammar is responsible for the management, ownership, and stewardship for the successful deployment of the DA Recloser program. Additionally, Ammar creates settings for distribution automation devices, as well as analyzes events involving the DA equipment. Prior to the DA group, he worked in distribution capacity planning as an area planner, where he was responsible for the overall normal configuration of the distribution system for select areas in both Chicago and suburban regions. Ammar received a Bachelor of Science in Industrial Engineering from the University of Illinois, Chicago. Please join me in giving a warm virtual welcome to Marina Mondello and Ammar Mirza. We are now going to assign presenter rights to Marina and Ammar.
All right. Well, thank you, Wayne, for the introduction. And thank you, everybody, for being here. So my name is Ammar Mirza, and along with Marina Mondello, we'll be presenting the distribution automation strategy and roadmaps at ComEd. So first, I'd like to start off with a brief summary of ComEd, an Exelon company. So our company is one of 6 utilities owned by Exelon, and we're a company of 6,100 employees with a service territory of about 11,400 square miles. We serve more than 4.1 million customers in northern Illinois, including the city of Chicago. Now, a bit about our grid here. Our peak load, which we saw in about July of 2011, was about 24,000 megawatts. And then we also have about 541,000 distribution transformers on about 67,000 circuit miles of primary distribution. Also, we have about 5,700 circuit miles of mostly overhead transmission lines. So let me start off by giving you a brief history of the DA program for ComEd. Our first automation was installed on our 34 kV sub-transmission system as sectionalizing switches in 1992. These switches were installed around distribution centers, which typically feed our 12 kV system. So our 34 kV program ran from 1996 to 2001, in which we installed about 800 automated switches by the end. And after our 34 kV system was built out, the first 12 kV automated reclosers were installed on circuits with poor reliability, which leads me into the next slide. Let me talk a little bit about our 12 kV DA program. So beginning of the early 2000s, we started to install reclosers at midpoints of feeders to break them into 2 segments, which definitely helped the safety benefits for faults in the back section. However, there was no customer-avoided outages for faults in the first section, and the whole feeder would trip. Then we started to install the normally open tie, which can now restore the back section when the first section had faulted. So then starting in about 2012, our strategy changed, and we began to pursue a 500 to 750 customer count segment. By then, we could install multiple reclosed devices, which meant that large feeders can now be broken into more than 2 segments. And we did this by utilizing the SNC Intel team for advanced restoration. here. In this next slide, you could see a history and progression of our DA installations. So starting from 1994 to now in 2019, we have about 5,400 DA devices on our 4 or 12 kV systems, and along with that, about 1,100 devices on our 34 kV system. And also, I just want to note that we will be continuing to ramp up for the foreseeable future for DA installations. So during the course of our DA program, here's some obstacles that we encountered. So first, as the installation of DA devices ramp up, these projects are becoming progressively complex and require larger company resources. So basically, the low-hanging fruit has been taken, and the installations are becoming more complex and require us to plan for larger budgets each year. Also, in densely populated areas, the need for innovative underground solutions like vault-mounted and manhole-type reclosers are greatly increasing. So for example, like certain areas in the Chicago region, we just don't have the real estate to install the DA devices, so we're looking to utilize these underground solutions to further segment our circuits. And last but not least, with our focus on delivering a premier customer experience and increasing customer expectations for uninterrupted service, we will begin to focus on multiple devices in series, which result in momentaries. So as you can see, our safety and KD numbers get better each year as we install more DA, but now we also want to focus on MAFI, which is the momentary average interruption frequency index. So there's some things to note here. I'm proud to say that in 2019, our safety and KD numbers were the best on record. And also, we do have other programs that will directly act in reducing the KD, such as our line sensor programs and NOJA programs at ComEd. So here you see an example of a proposed project diagram for a DA scheme. You could see how complex our schemes are getting here while we try to implement our customer segment strategy. You know, there's a team here that spans over 7 feeders with over 20 devices. And you can see some multiple devices in series, along with some traditional loop schemes that are being converted into a larger interrupter scheme with the use of IntelliNodes. So you can see here how real estate might be an issue. Let me go here to the next slide, the future of DA. So now I want to get into the future of DA, which is where we're trying to pilot a new protection strategy. So on the left side here, you see our current philosophy with multiple devices in series. And this scheme has a time-delayed coordination, which means that all devices upstream of the fault operate on fault current, which definitely increases our MAFI. And as for the time-delayed restoration, all the normally closed reclosers and ties wait an allotted time before they close to restore. And this scheme communicates over our OMICRON radio network, which has a greater than 1 second latency. So for example, if the fault is between device 3 and 4, all devices upstream would trip and and wait an allotted time before reclosing. Device 3 would stay open and device 4 would open on loss of voltage. Now we want to shift our attention to our new philosophy here, where we want to, on the right side, where we want to pilot a communication-assisted advanced protection strategy. So this has communication-assisted tripping, which isolates only the faulted segments, which results in our MAFI reduction. Also, the high speed would help with reduced fault current escalation and arc flashes. As for the communicated assisted restoration, this has faster tie closing for reduced momentary durations. And this scheme would communicate through our fiber optic cables, which has less than 1 cycle latency. So some things to note about our new philosophy on the right here. Each device will only communicate to its neighboring devices. And then if a device senses overcurrent, it will send out a signal to its neighbors. And each device needs to see 2 signals to shift to its slow tripping. So for example, if a fault occurs between device 3 and 4, the circuit breakers and device 1, 2, and 3 will detect a fault current and signal to its neighbors. So since device 3 did not see a signal from device 4, it did not shift to slow tripping and opened, and then device 4 opened on loss of voltage to isolate the fault, so saving momentaries to everyone upstream of device 3. And so now below are some challenges and solutions that we came across for our new philosophy here. So one of the challenges we have seen is our multi-vendor schemes. They result in interoperability challenges amongst various platforms. And then there's some vendors that just do not support the standard IEC 61850 protocol, which results in situations where advanced protection cannot be applied without actually changing on devices. And also we'll need to increase the lab testing time to run through all these different scenarios. So we are pushing the industry to support standard protocol to enable these schemes between multi-vendors. But for the short-term solution, we're trying to utilize controllers that support IEC 61850 protocol, where applicable, to allow for scheme deployments. Next, our holistic settings approach. So beyond our advanced protection scheme, what else can be improved? So in order to do this, we're involving multiple stakeholders in the development of the actual settings, and we're benchmarking learnings from EPRI regarding conductor slab and fault locating. And as with anything new, training is a big challenge, right? We're deploying a technology that's has not been previously utilized at ComEd, and we're also completely shifting in the DA protection scheme philosophy, which again will require adequate lab space and training and testing. So for this, we're currently developing training materials to roll out to all the stakeholders. And we are happy to say we have procured adequate lab space for training and testing. And this training, once complete, will be communicated to all its key stakeholders. And I know, OMICRON's CMC and ARCO units would be used to test all these types of reclosers in the labs. So this is a basic summary of our pilot for our new protection strategy. One thing to note is this is brand new to the DA group at ComEd, and the details are still being developed as we go through the growing pains. So there's definitely going to be some more to come in the future. And now I want to hand it over to Marina Mondello to talk a bit about DER. Thank you.
Thanks, Ammar. So, as Ammar mentioned, ComEd has been deploying DA for well over 20 years now. So we have a somewhat advanced DA system at ComEd, but we're starting to see an increase in DER applications due to incentives that were approved in late 2016. So as we start to see an increase in DER or solar applications on our system, we've seen quite a few community solar installations, which looks to be the sweet spot for the incentives currently. What we've seen are quite a few community solar 2-megawatt solar farms coming in on our system in the middle of a lot of our DA schemes in our rural areas. And part of the issue that's come up is load masking. So what happens, and I kind of want to go a little bit to what the load masking issues that we're seeing are. So on a 34 kV line, to have 5 megawatts of solar, in the example that's on the screen right now, contributes about 84 amps to the section of line between switch 1 and switch 2, with some load supplied by the utility, for a total of 109 amps in that section between switch 1 and switch 2. The automation at the switches only reads a 25 amp contribution from the utility. So the automation is only thinking that there's 25 amps of load in that section of line prior to a fault, with an additional 75 amps between switch 2 and switch 3. For the fault scenario in the first section, the breaker will trip and go to lockout. The inverters will shut off immediately after loss of utility. Switch 1 will open And then the automation will calculate the load that is going to pick up with essentially switch 3 closing to pick up what it thinks is 100 amps. But with the solar offline, it will actually close to pick up the total 109 amps in the sectional line between switch 1 and switch 2 for a total of 184 amps. So the automation could end up picking up 84 additional amps from what it calculated it was going to restore, which could potentially overload line 2 or cause low voltage issues or system violations, which is obviously something that we do not want to design for. So as we deploy more DER, there's a lot of considerations that we're giving to how to incorporate DER into our automation schemes. So for example, for interconnections at 1 megawatt or greater, we're including a DA device at the POI to be able to integrate into an automation scheme. And from our discussions with other utilities, that sounds somewhat standard with what a lot of other folks are doing as well, to try to build for the future. We're also working with our vendors to be able to incorporate that DER as we have. As a lot of our initial automation schemes are more designed for one-way flow, we're working with the vendors to integrate two-way flow and the ability to calculate that DER contribution into the automation physical logic. As Ammar had mentioned, there's the increasing complexity of feeders where we're at now. Part of it is due to we've done a lot of the easy feeders, and now we have a lot more of the complex ones to install automation on. In addition, as I mentioned, we have increased DER penetration. We're also deploying a VO. We're in about the second year of a VO implementation on our system to install voltage optimization on most of our 12 kV state substations. So part of the complexity comes in, we tend to design everything for normal configuration, but as this system switches around, how does everything integrate together? And that's why this slide on the next slide that's up right now, we have to stop thinking about just a DA scheme or just DA or VO or DER, and really think of it how everything operates as a system as a whole, because it's becoming more complex to anticipate what's going to happen in N-1 or different scenarios on the system, and increased awareness to what the potential risks to the system are. So we've been working with trying to do some RTDS studies of our system to try different scenarios to try to understand the different potential risks with the different technologies that are coming on. That is, I believe that's all we have from ComEd, so we'll go ahead and open it up to questions.
Thank you very much, Marina and Ammar, for another great presentation. Really much appreciated, especially your comments there at the end about looking at the holistic approach to the system. You guys are certainly leading the way in a lot of ways at ComEd, and I know you were and are the host of our upcoming IEEE T&D, which will now be in October, and thank you as well to both of you for your leadership with that event that will be coming up in the fall. I'll now turn the mic again over to Eugenio. I'm sure there's been some more questions posted by the group. Eugenio?
Thank you, Marina and Ammar, for the great presentation again. So I have a question here, and I think it refers to one of the slides that Ammar shared, where there is a radio system. And the question is if those distribution circuits are in a loop as well, like a network.
So I think the slide I showed was for 12 kV. So we typically do not loop our 12 kV feeders. They are open ties at the end of those feeders. So I think you were talking about, I can't switch the slides now, but so no, those feeders are not looped.
Okay. And also another question that came in, does your pilot protection have backup logic in case a communication link is lost?
Yeah, again, currently, like I said, like this is kind of still in the infancy stage, and I do not know the answer to that. I don't know, maybe Marina, would you have any input for that one?
So for the pilot, I believe we're looking at utilizing fiber, which I believe I'm not sure if the previous question was about the communications being looped or the feeder being looped. I believe the fiber is going to be looped, and so I believe in the communication medium there'll be backup. I'm not sure, and I'm not sure. I believe for the DA schemes, the backup will be that all the devices will trip if the communication enhanced coordination does not operate. I believe that will be the backup from the protection perspective.
Okay, thank you.
Thank you.
There is another question coming from Peter. Are you utilizing transfer trip for the advanced automation scheme? We're
requiring transfer trip, and I'm trying to recall what the criteria was. I think it was for 10 megawatts of non-inverter generation is where we're requiring transfer trip right now, I believe. So for our inverter-based generation for the DERs, we are not, for the ones that I had mentioned, the community solar, we are not requiring transfer trip.
And another one, what challenges are you seeing with protection schemes and with the DER integration?
So we haven't seen a lot of larger DER come online yet. We're starting to see, prior to 2016, we had maybe 300 applications a year. Now we're up to about maybe 1,400 a month, give or take. But primarily those are residential, so we haven't seen a lot of issues. With some of the larger ones, because they're not online yet, one of, I guess my concern is the ability of the inverters to shut off when you have multiple inverters on a feeder, and then detecting the loss of utility. I think it's one of our concerns that we have, and that we want to kind of see what other folks are seeing with those fault scenarios, with the inverters following each other.
Okay, thank you, Marina. And there is a question that I think it's related to one of the slides you showed when you talked about testing. What kind of challenges are you currently experiencing when trying to test your DA protection scheme as a whole?
I mean, like I said, currently just having multiple vendors on the system and them not supporting a common protocol is the major challenge that we are seeing here.
Thank you, Ammar. Another one coming from Scotty. Are they planning on using the iTron, or are you planning on using the iTron radio network for the 650 deployment? If not, what will they be utilizing, or what you will be utilizing?
No, I think we'll be utilizing the fiber to deploy 61850, just because you know, the latency issues over and just the communication issues over the radio networks.
And I think one of the slides that you showed as well was the new approach. You show, I think, more a decentralized solution, and I will tie with one of the questions that I have here in terms of if you or if your ComEd have any plans for utilizing a centralized controller as well.
So I think, I'm sorry, go ahead.
Oh, go ahead, Ammar.
So I don't think currently, I don't think there is any explicit plans to do that yet, but I mean, we are in the process of trying to get an ADMS, and once our fiber network is in place, that might make sense then. But I don't know if you have anything to add to that, Marina.
I think that part of that comes to that's where I go to the site that I just moved to now. It's we're taking a look at implementing a DERMS. So as we take a look at different technologies, more DERs on the system, and that kind of leads a little bit to, are we going to need something that looks at a system at a system level to control and to control the automation system? I think we're still developing that part of our roadmap for what we're going to do for that. But the longer term plan is to end up moving to an ADMS that would potentially have FLISR modules, I believe. As well as decentralized intelligence as well.
Thank you. We have more questions coming in. We have time for one more. So how long has ComEd used the 62850 or the DA versus the NP3? Or if you used any other protocols in the past as well?
You know, I'm actually not sure about that one. Dale, if you're on the call, would you have any response for that, or Marina?
We've used the DNP3 for most of the time that we've been installing DA. The 61850, I believe we're right now in the process of deploying that pilot. So that's pretty new to us.
Yeah, that's something that we're still piloting right now.
Okay, well, thank you, Marina and Ammar, again, for the great presentation and answering all the questions.